1, 2, and 3 are all about hyperbolas. So we'll start by talking about hyperbolas with their center at the origin, and we'll work on finding their asymptotes. And then we'll analyze hyperbolas where the center is shifted and look at an application problem. So a hyperbola is a geometric figure, Hyperbola, hyperbola. So the first part is different, but the last part is like parabola. So it's the collection of all points in the plane where the difference in the distance from focus 1 to the point, so the distance from focus 1 to the point, minus the distance from focus 2 to the point is constant. So with the ellipse, it was the sum of those two things was constant. With the hyperbola, it's the difference of those two things that's constant. So those 2 points are called the foci, and the hyperbola has more parts than any of the other shapes we've looked at. So there's an axis that goes through all the key points, and that's called the transverse axis. It goes through focus, vertex, center, vertex, focus. So that's the transverse axis. Then the conjugate axis goes perpendicular to the transverse axis through the center point. Then the center is situated in the center. It's not a point on the graph of the hyperbola, but everything is related to the center. Of how far away is it from the center? Then we have vertices, which are points on the hyperbola. On the ellipse, there were the points farthest away from the center. On the hyperbola, they're the points closest to the center. So those are the vertices. Then we have the foci, and in every shape we've looked at, the parabolas, the focus is inside the curved part. The ellipses, the foci are inside the curved part. In the hyperbola, the foci are inside the curved part. But see how that means they're farther away from the center than the vertices. Then a hyperbola also has these 2 lines called asymptotes that the arms or branches of the hyperbola approach. And you'll hear the 2 pieces called branches and also sometimes called arms of the hyperbola. So it has 2 separate mirror image pieces. So when we look at a hyperbola with the transverse axis along the x-axis, I call this one opens right left. So I'm thinking about the hyperbola as kind of C-shaped pieces, and I'm saying it opens to the right and left. So the equation for that hyperbola looks a lot like the equation for the ellipse. But where the ellipse had a plus in the middle, the hyperbola has a minus in the middle. So we have the point called the center, and here it's at the origin before we have it shift around. Then if you look under the x coordinate, this part feels a lot like the ellipse. You go a distance of a to the right and left and make dots. And then you go a distance b up and down, and that makes a box that we'll talk more about, and the diagonals of that box make the asymptotes. So when the transverse axis is the x-axis, see how the arms of the hyperbola cut through the x-axis and the x term comes first. Because there's a minus, the order now matters. So we can also have a hyperbola with the transverse axis along the y-axis, and notice that then the y term comes first. Everything else really follows the same way of under the x term, you go a distance of b and negative b and make dots. Under the y term, you go a distance of a and opposite of a Then we'll use those dots to make a box, and the diagonals of the box will give us the asymptotes. So this is where the transverse axis is the y-axis. We're going to call this one opens up down. And you see that if the arms of the hyperbola are cutting through the y-axis, that the y term comes first. Okay, then you could remember these equations of asymptotes, or I'm going to show you a way that I just find them from the work of drawing the picture that goes with the equation. So these are the equations of the oblique asymptotes. But rather than memorize formulas, I'd rather if you understand where those formulas come from. So let's look at an example. So A is the equation of an ellipse with the center at the origin. Let me label my axes, x and y. In the x direction, I go a distance of 2 to the right and 2 to the left. Then in the y direction, I go a distance of 4 up and 4 down. And now I'm going to use those dots to draw a rectangle where the dots are the centers of the sides of the rectangle. So there we go. The dots are the centers of the sides of a rectangle. Then draw the diagonals of the box. And those are the asymptotes. And then we can figure out what the slope of the asymptote is by looking at how it got made. Starting from the center, we go up 1, 2, 3, 4, up 4, over to the right 2. So my slope is 2. So rather than trying to memorize something with A's and B's and ratio, I just draw the picture and figure out what the slope must be from the picture. Then these slopes are always plus and minus the same number, because you see to get the slope of the other asymptote, you go up 4 and backwards 2, which gives you a slope of -2. So the asymptotes are one of the first things I find. And we have y equals plus or minus 2x. Okay, so I got my asymptotes. The center is 0, 0, since we're starting with the center at the origin. The transverse axis, so we can't go by which way is bigger this time, because the hyperbolas don't work that way. That's different than the ellipses. We look at which term is first, and we see the y term is first. So the hyperbola must actually cut through the y-axis and not touch the x-axis. So we know it opens up down. So we can see that the transverse axis is the line x equals 0, or you can say the y-axis. Either of those is fine. Okay, so we've got our transverse axis. Then I can look at my picture and see where the vertices are. So 0, 4 and 0, -4, those are my vertices. Then to find the foci, we look at these two denominators, and little c squared is the sum of the denominators. So the ellipse, the formula has a plus, so the c squared has a minus. For hyperbolas, the formula has a minus and the c squared has a plus. So c squared is 20. So c equals plus or minus the square root of 20, which you should simplify to plus or minus 2 root 5. So we know the square root of 20 is between 4 and 5. So we know about where our foci are, because little c is the distance from the center to the focus. So just like with the ellipse, c is the distance from center to focus. Distance, center, focus, all those c's. So we know that's 2 square root of 5. So the foci are going to be found at 0, 2 square root of 5 and 0, negative 2 square root of 5. And when we allow the center to shift, you'll see that you are just going to add and subtract 2 root 5 from whatever the y coordinate of the center might be. Okay, so we found all the things we were asked to, and we graphed the equation, so we're done with this example. Okay, now let's look at this second example. I'm going to leave these words here about c is the distance from the center to the focus, because I think that can't be said too many times. So now we see that this equation has a 4 on the right, but we know there has to be a 1 on the right for ellipses and hyperbolas. So we're going to divide both sides by 4 and get x squared over 2 minus y squared over 4 equals 1. So I'm going to draw my axes, x and y. My center's at 0, 0. In the x direction, I'm going to go plus or minus square root of 2, which is about 1.4, but I can show on my drawing that it's exactly square root of 2. And when the x term comes first, the points you find by going in the x direction are the vertices. So these are the vertices. Then in the y direction, I'm going to go plus or minus 2 starting from the center. So up 2 and down 2. Then I'm going to make my box where these 4 dots are the centers of the sides of the rectangle. Then I'm going to draw the diagonals of the box. These are my asymptotes. And let's see, what's the slope of this asymptote? I'm going to go up 2 and over the square root of 2, which I should simplify to square root of 2. So my asymptotes are going to be y equals plus or minus the square root of 2x. Okay, let's see what else we need to find. So we know the center is 0, 0. The transverse axis, we can see that the center and the vertices are lined up on the x-axis, or you can call it the line y equals 0. That's its other name. Then we can see the vertices. So the vertices are root 2, 0 and negative root 2, 0. And then we need to find the foci. So little c squared is the sum of the denominators, or 6. So C is plus or minus the square root of 6, which is in between 2 and 3. So I know the distance from the center to the focus is square root of 6. So my foci will have coordinates of square root of 6, comma 0, negative square root of 6, comma 0. And then I can draw my graph. It needs to touch the vertices and approach the asymptotes. Touch the vertices and approach the asymptotes. And there we go. So I'm going to pause here and make another movie so that they stay nice and short.